Now, when an earthquake takes place, seeing that infrastructures would have been destroyed, you expect, for example, diseases outbreak. Number one, there's no food, there's no water, medicines are scarce, basic sanitation capabilities are disabled, hospitals are damaged or destroyed, health professionals are overtaxed. There are just too many to deal with. So is, for example, decaying corpse, people that have passed on. So all that devastate the whole situation. Now, earthquakes are associated with tsunamis or seismic sea waves, which should not be confused with tidal waves. Tsunamis results when an earthquake changes the sea floor. Normal faulting drops the seabed, thrusting starts to rise it. This displaces the entire volume of underlying water, and a giant mound or trophy form on the sea uh, surface. This creates, or this future may be enormous, as big as 10,000, for example, square miles. And what happens is that futures start to collapse, that create waves that moves rapidly away, and when it reaches uh, the shore, everything on shore, and for example, buildings that are closer to the sea would be destroyed. So that's why tsunamis are very much devastating events that increases even uh, or that kills even much more people than what an initial earthquake might have achieved. So what you can see here is how tsunamis distinguishes themselves from wind waves. Uh, Wind waves influence only the upper 100 meter of the ocean. Tsunamis, the entire water depth is uh, displaced. Uh, Wind waves have wavelength of some uh, 10 to 100 seconds per meter, if you like. Whereas for tsunamis, it's different. So now wavelength is directly associated with the amount of energy that such a tsunami can displace. For example, if you check here 10 to 100 per meter and 10 to 100 per kilometer, you expect that this will have a much more larger amount of energy compared to here. And that is the reason why it's much more destructive. So if you are having a good time somewhere along the ocean at some point, and you find this high rise uh, wave much more higher than the normal waves that you would find when you go to the beach, uh, that could be waves triggered by tsunamis. And the best is to basically vacate that place for your own safety. So if you are evading a tsunami, expect that the roads would be impassable. The best is to climb on a tall building or a tree, or the best is to grab something that would keep you afloat, and expect a lot of debris, sediment, wreckage, corpses, and the likes and expect that the landscape would change. There has been instruments developed to be able to, for example, model or predict tsunami behaviors, and those somehow can help us to be able to tell whether or not there is a tsunami along the way. So, seismic risk and how much can we predict is that long-term prediction of an earthquake is possible. For example, say there's a likelihood that an earthquake would take place the next 100 years. But accurate short-term prediction, for example, in terms of hours or weeks, not possible despite extensive research that has been done. So prediction can largely be done based on the identification of seismic zones. So is the reoccurring intervals. If you know that a certain mountain erupt every 4 years, and you know that 4 years have lapsed since then you know that uh, there is a likelihood that the next earthquake is near. So that is very important for you to understand. A global seismic hazard assessment program has taken place and has created several zones, including in Namibia, by saying that if you are located somewhere along the Himalaya mountains, not the Himalaya mountains, somewhere along the Brandenburg Mountains in Namibia, uh, the chance of you experiencing an earthquake is much more higher compared if you are located to somewhere in Botswana or somewhere in Kavango. So know where you are to be able to tell whether or not you are safe in terms of earthquake. We have come to the end of our discussions with aspects related to earthquakes. Uh, so we would continue with our very last unit and we take it from there.